In this video, I'm going to talk about how AI coding agents interact with your workspace. In other words, if you use something like antigravity, how this antigravity works with your multiple files and your command, and how this interact with the large language model on the cloud. And this overall package is a product of context and harness engineering. Now, let's take a look at what is a context and what is harness. In the previous video, we talked about that when you give a LLM a very good context, it's able to act as if it has a memory, it's able to act better than just a simple instruction. So context is useful, depends on what your target is. For example, if you're going to analyze a small data set, you can tell the LLM that what's the data set look like and what do you want and what kind of model are you looking for. So it's able to give you some instructions about how to run a regression or whether just do some descriptive statistics analysis and so on and so forth. But if you give it additional context, but not very related to the problem at your hand, then you still probably get a good result, but it's likely to be noisy. Okay, so we want to make a good signal-noise ratio that given to the LLM so that we can expect a better result. Okay, so a context engineering aims to do so. So it wants to give the right information with the right amount at the right time to the LLM, depending on what you're doing. So this is very interesting. So if this can be done automatically, that saves a lot of your copy-paste time. The harness, in comparison to the context, is a different concept. The harness itself is to give your model hands and the tools so that the model can actually do things for you. Right? So when the model takes a string or a sequence of tokens in, it only give up a token. That's the only thing that LLM do. It do nothing else. It only give the next token prediction. That's the only thing. And it will not do anything else, even in the future. But the harness itself works as shell, or you can also say it works as some scanning machine that keeps scanning what is LLM talking about. And if it talks about do something, it can quickly pick up the task and execute it. So that is harness. So harness works as the neural link and also as the hand and the muscle for the brain. So that is harness. If you consider harness the body, LLM as a brain, together they can make something happen. And the context itself is the environment of the brain and the body. So imagine you're in a certain area, right? So you know what is around you, you can see and you can move. That's basically what daily life is. A quick compare about web chat and this workspace agent. Narrowly speaking, I just say workspace agent is just something saved on your computer. And workspace is just some directory or folder on your computer that you want to work on. Okay, web chat itself is self-explanatory. So when you do web chat, clearly the context, you have to copy and paste by yourself. If you ask for coding, the web page gives you some piece of code and you need to at least click that little copy button to copy the code and paste on your own computer. So in that sense, you are a harness. So you are the hand of AI. So you AI's agent in that sense. Okay. But if you have workspace agent like antigravity or VS Code with certain extensions, the story is different. Okay. So it's the agent is able to find context because the model can say, hey, help me to look at the directory, help me to list how many files you have. This looks like something I want to read. Can you read for me? Then the model can make instructions and the agent will follow the instructions For example, if you want to read a file, it's going to read a file and copy that particular content and give it to the model. So this is already done in the background. So we, as users, we do not have to even know what's going to happen behind. We just know it happened. And it also can make code executions. After code execution, if it's successful, it's going to say, hey, it's done. If unsuccessful, well, there's error message. And it read error message, and the model on the cloud will make decisions and send new instructions, and agent will execute that again. So everything here will form a loop until the task is done to save you a lot of human time. So this is, I think, this is the major drive why we need AI agent. Right? The ultimate motivation is that humans are lazy, but we're smart enough to conquer this laziness by creating tools. Now let's take a look at this agentic tool belt to see what the ability does anti-gravity have. I want you to pay attention that it's not necessarily only limited to anti-gravity. Okay, there are many extensions, Cloud Code, Codex, and all kinds of extensions, and Pillow Code, and Windsor, to name a few. And there are so many of them. The reason we use anti-gravity because it's kind of new, so it has some interesting capabilities. Now, there's also no guarantee in the future. There's nothing is better than that, right? There must be something better than in the future. But if you try a few of those coding agents, you may realize they look like very similar. So the learned skills can be easily transferred from one to the other. Now let's look at those 6 items one by one. The first, context sensing and discovery. Okay, the agent, okay, it has the ability to decide which one it wants to see. This is great because usually when you have a project, the project can be large. Okay, if you have data and something can easily be more than 1,000,000 tokens. So if you just give all of them, that's just become really impractical and sometimes it's disastrous. But usually our directory are organized in tree format, right? You have folders, you have subfolders, and so on and so forth. When you deal with some little task at a time with a limited human brain power, you just look at a small part of it. Same for LLM, okay? When it wants to do a task, it doesn't need all the information. You only need related information. So let's take a look at context, okay? So instead of stuffing these massive directories, okay, the agent have a tool-driven approach to discover the context dynamically. So it can help to see, for example, in your IDE, you have some open files. So the context will sense that, oh, you probably are working on these files, okay? And your mouse selection, like this, right now I'm selecting this mouse selections. I use mouse to select mouse selections here. And it also can sense that as well, okay? It's also able to try the directory finding to read related folders, and it can view files at its discretion because it's smart enough. There's some example of context that can be fed to the LLM via the AI agent. This part, you do not need to type this yourself. The agent, or let's say anti-gravity, will detect and send this automatically. For example, here, right, it said your current open file is this one. Your current cursor is right here, right? And you probably have selected these lines and you have some selection about this. So this is some information will automatically wrapped. It will be scanned by your AI agent and send it to the brain on the cloud. Okay. And it also has the ability to list different file names and view some certain files. And it can also, if it think some of the code is useful, it just takes some snippet and also paste there. So everything here is automatic. We do not do this. The LLM do that. Autonomous planning. Okay. So this is a typical intermediate product from this anti-gravity. It's called a task MD. So MD is markdown file. So it's just a way to write text, just make it a little bit easier to view than the plain text. but also simpler than the HTML, so it doesn't have too many marks. So this markdown is kind of the middle way to satisfy human for convenience and complexity. And this task is called an articraft. This is an intermediate output from antigravity. And this just look like this. So when you ask antigravity to produce some output, it doesn't give you output right away. It will have a chain of thought to have some reflections in your mind. And they're going to give you, oh, here is what I'm going to do. I'm going to create implementation plan. That is how I'm going to do it one by one. And then I'm going to make this implementation plan into a checklist. It's called TaskMD. Then this is a typical example of the checklist. For example, if you want to do something like read CSV file and then make the data format logic and so on and so forth, and these are sequential. And after the checklist has been made, then the AI agent will going to execute them one by one. So at first it reads this, oh, if I'm already at this stage, so this reading is finished, I'm going to do the refactor tasks and so on and so forth. This is also similar to our human working plan, right? So you have a plan to work on certain tasks. You usually make a list. You need to check them and then the task is done. This mimics human. And it turns out this works well. There are so many ways that if you make the LLM to think as a human, that works better. Well, that's not surprising. After all, the AI is trained by human knowledge. So whatever works for human, it should work for the artificial intelligence. So this is the working flow of antigravity will do. When you try to do some task, you can see that it will automatically pop up those two files, implementation plan and the task. And you can also make some revisions on it as you like. The third one is called interactive user feedback. So whenever the requirements are ambiguous, the agent will ask you a question. This is actually great. So previously, when the model is weak, it just execute blindly, just try to make people happy. But nowadays, the new model, the new brains has the ability to say, if I want to finish the task, I shouldn't just finish a task for that particular single-minded path. In addition, I want to do it right. Right? That is the ultimate goal. If I do not have enough information to do it right, I should ask for more information. So this is also part of the context, but this is kind of interactive context that the model requires from you. Strong models usually have this, but you can also augment it with a certain skill to ask it explicit to ask question if things are clear. So there's some ask question tools exist, and you can also view their plans, right? For example, if you do anti-gravity and your task is not, if it's clear, it won't ask you. So if it's not clear, in the agent interface, you can see something like this. It will ask you a question, right? If you want to make plot, it may ask you, do we use this or that? Just to make sure, because both are kind of nice, okay? And then if you choose someone and then he make a new plan, he said, do you want to proceed? You can approve or just proceed and something like this. So this is the interaction between AI and the human before you carry out the task execution. Supervised execution sandbox. Okay. So there are multiple ways to run the AI agent. One is to run this on your computer, so it has more flexibility, more power to execute. Another one is called sandbox execution. Sandbox anti-gravity is just if you work in a folder, your AI agent can only interact with something in the folder. It's not able to jump out. And this kind of confinement is defined by the app with this very hard-coded restriction. So it cannot really go out. So sometimes I feel Sandbox is too restrictive because it can even read outside, but this is for your own safety. So if you're unfamiliar with how this AI agent works and you're unfamiliar with some terminal command, it's highly recommended you start with the Sandbox mode. That is what it is. Okay. And if in a sandbox it feels restricted, want to do something, it will ask, can I do this, for instance? And come back to my old argument that if you do not know what's going on, then you are AI's agent. If you really know what is going on, what is the code about, and what it's going to do is really dangerous, then AI will be your agent. Okay, so we need to just learn more knowledge in order to make a equal conversation with your agent. Now, external MCP extensions. AI agent is powerful. It's like if you use Python, it's powerful enough, but when you do specific tasks, you still need to install new packages. This MCP is called Model Context Protocol. The names could be confusing, but the name comes from Anthropic first, so we probably won't be able to change it. This is just LLM's package. Okay? It has a certain ability to let LLM use some tool better. Okay? Current LLM is super strong already. For example, if you ask it to do some GitHub management, you probably don't need to install the very hardcore GitHub CP. But if you have it, it can just do much more faster and better and reliable. So there are multiple MCP. If you use MATLAB, MATLAB has official MCP server, and there's a Chrome developed tool, so it can manipulate your Chrome browser and Wolfram server. It helps you do some symbolic computation and so on and so forth. And this kind of package information, you just view this as a weaponry for LLM, right? Your AI agent already has hands, has a brain, that is LLM, but MCP looks like you equip with a gun, additional a knife or some other weapons or shield, so it can be more powerful and stronger. And this is one example, JSON code. You just tell the LLM that, hey, look, this is a new method that you can use. You can call this MCP and you can do something like that. There's some example argument. You can solve this. So this is a typical call that LLM can make in order to do some numeric analysis. So when it calls this kind of problem, solving the equation, goes to the server. The LLM doesn't to solve it himself. Okay, so the model doesn't have to use his intrinsic power. Might be wrong for symbolic computation, but can trustworthy give the credit to this Wolfram server. So it doesn't have to do by itself. Now, self-creation and code generation. So the agent is able to create temporary workspace to execute code and do some tasks. Right? For example, if he wants to test how many variables in your data, and it has two ways, right? So probably one way is to read your whole data file and count how many columns are there just as a big text. And usually AI agent or just LLM, the brain, will not do that. Instead, brain may just write a Python code to say, hey, let me load the data and show the number of columns of the variable. Then I'll know. So I don't have to read all the numerical values in order to understand it. So that is what agent do. So it can write scripts, and then after script, it can show this number of columns and even to see, for example, here, what is wrong and is this valid validation schema. It can write small code to do its own task. So how to initialize this context in AI agent? So at the start, it reads your environment, read your system, right? So are you in a Mac? Are you in Linux? Are you in Windows? So such information will be compiled and say also workspace to see where you are. For example, if I work on here, this is my current working directory. So which file am I working on? Where is my cursor? And do I select anything yet? And there's could be even more. What is current open tab in the IDE and so on and so forth. These are the working environment that's related to your user experience. This is something will be given to the to RM as a big mass, part of the big mass. Now, behind it, we do this state capture. That's the starting point. That's actually this one. I think I put it here intentionally just to say what's actually the difference between if you copy things to the website for ChatGPT or something else and AI agent. Usually this is something we do not directly give it to the web-based AI. This is automatically collected so that RAM knows what you are, so it can send the right command. For example, if you're in a Mac, the command to execute copy or reading will in general different from a Linux and Windows. So that is a key information. Right? If it doesn't know, then it cannot issue the right command, and so the AI agent cannot execute it correctly. Some information from the system, and the AI agent will assemble the context together and stacking them up. So this information include the previous page we talk about, where the cursor is, how many tabs are opened, and so on and so forth. This is a basic state capture. And then you're going to find global configuration. You load this general rule. This is if you use antigravity, they usually use a Gemini.md as the master file to tell, hey, this project is such, such, and such. There's some key important folders you need to pay attention to, and which stage am I at. So you read this as a constitutional law for whole project. Okay? And also it look at project level skills. Skills are sets of prompts that can help the agent to do certain task. So this is a harness configuration. And also it will load this MCP's information as well. What kind of tool do we have? What's the basic command we know? And what is the tool schemas that we need? And so on and so forth. And do not worry too much. If you install MCP, you know what you want. Everything rest or all automatic. This is automatic. This is automatic, but you need to edit this one, but it's quite easy. And after installation, this is also automatic. After you get all the heads, configurations, the weapon tree, and then it starts to add your conversation to it. So you see the huge amount of context will be injected, and now is what you ask. And format system blocks and ship this API payload. That means everything 1, 2, 3, and your prompt together will go to RM. Okay. So although we have input a lot of things, actually you can see the context that we talk about is not everything in your project. It only loads the related file. For example, the file you opened, the tools. It doesn't give all the files content to LLM. It only gives the tools, the starting point, the basic structure, and the file that you open. And it's not even the content of the file you open. It just tell the LLM what file is opened. So this kind of hierarchical index, you have a tree. When you're dealing with each leaf, you do not have to look at some leaves that are uncorrelated to it. You just go through the branches, find a leaf, and solve with it. So this is kind of a hierarchical structure that made a bigger project available for AI agent to deal with, right? Otherwise, if you tuck full entire code base as a prompt and give it to LLM, the context will explode. You can never solve any problem. It's just disastrous. Okay, but if you can use AI agent to carefully select the best signal to noise ratio information, then the LLM can solve the problem much better. So you can see, even for the same brain, if you have a better harness agent, you can still works better. So the agent and the LLM together determine how efficient you can do your task, right? If you have a good agent but a very poor brain, you cannot do at all, right? Just an idiot with a lot of good weapons. But if you have a bad agent, but you only have a good LLM, you cannot do things either because it just won't give you any efficient tool executing method, and also the context can be really, really messy. Now, let's look at another super good thing about context compression. Right? So start when your conversation with the AI agent longer and longer, you may realize that it doesn't decay the conversation quality that much as you do in a regular web-based conversation. The reason is because AI agent has a way to compress the past conversation more efficiently. Okay? So let's look at this 4 points to see how they make good compression. Okay. The first one is called checkpoint summaries. For example, when you start to talk your AI for a long time, and then when the context is really long, you will think about a way to make summaries. Okay. So for example, stateful truncation, when context approach token safety threshold, it truncates early turns, compiles a checkpoint. So it's not only to say I'm going to throw information away. Instead, I summarize it. This back to our human sense, right? So if you talk to somebody or for too long, you try to remember what you said to your friends a month ago in the weekend, you probably remember a few key points, right? For example, if he has achieved something and what you have eaten, but many of the small conversation you hang out on that day might just disappear. But that won't affect your overall quality of the current task when you still talk to the same friend or talk to a different friend. Okay. So for example, in the previous, you have a lot of conversations. There are 45 lines of code and so on and so forth. And after lengthy conversation, this become a far away history. So what do you do? So actually, we don't do, right? The AI together, right? LLM and agent together, they work on, okay, how about it's time to summarize? Then AI agent feel is too long, but he doesn't know how to summarize. So he gave the task to the LLM. The LLM will summarize. Okay, so all right. So since I did this particular error fixing, I just say I don't need to paste this multiple lines here. Just say, okay, this is file here. They're done. Okay, or they're still pending in this place. And the task is left okay. You do have to see everything. That is the summary. Okay, so also there's a structured preservation. It's the history, just summarize the history into key states. Okay, some of things get rid of, but some of things are summarized at their discretion. Honestly, we do not know what is really truncated. But in this simple example, we know the code is truncated and it's summarized as, oh, the code is in the file. If you want to read it, you can still get it, something like that. So how exactly does it do this? We do not know because AI agents keep improving. Whenever there's valuable research paper about, oh, this particular point, we can do something, the research and engineer may just incorporate that particular discovery inside. So you can see the versions are improving step by step. But the overall idea is quite straightforward. When it's long, we do some truncations and do some summaries so that the truncation can be properly taken care of without losing much information, and the summary has the key information that's left for us to refer to if we really want to. But usually when you talk for so many rounds of conversations, the far history, you probably won't remember that either. Now, to output pruning. Okay. So this is read files. The tools read files contain compile outputs, emit hundreds of lines. This could be necessary at the beginning because you're debugging the code, for example. But in the next round or a few round conversation after, is it necessary for us to keep these 800 lines of code in every round of conversation? Since we're not talking about this anymore, how do we do that, right? Because you have so many lines of code, it's certainly the attention will be diluted, so many tokens, and even we're not even discussing it, right? How do we do about it, right? So what's this AI agent do? is actually in round one, you read the file and then the model will read it. But even in round two, if your question, right, is not that related, and you will say, okay, we just truncate it, we tell him that this line has been successfully read. And there's also could be that key information summaries are right here. Okay, this two output pruning is kind of similar to the checkpoint summaries right here, right? The checkpoint summary is that, okay, what happened in the past, and let's make a summary. And the two output is more particular related to the code, right? If you call a large number of observations, and those standard observations probably only useful in the current setting. And they are of least checkpoint summaries and two output prunings are actually from my point of view, are quite similar. They just truncate and summarize. The difference is this checkpoint summary is when the history is very long, you think about how to do that. And this two output pruning is not history, it's just because you're reading the code or reading some files. This is too long, and after reading, we do not want to keep it there. We just need to summarize this right away. Okay. The third is called state overwriting. And this is probably easy to understand. When you move your cursor, the previous here, now here, in the previous round, this is what you give to the LLM. And you really do not want to give it this again, even you have a new one, right? These two shouldn't show up at the same time. So this is not, shouldn't be summarized. This should be removed because your cursor has changed. So you should overwrite the previous metadata to make sure that your state is correct. Now, the last one is called the lazy schema. I'm going to use MCP as an example. MCP can be viewed as a package for LLM to use. Some package is small, some package is big. Right? So if you have a super big package and you're not using it, you probably don't want to just give all the information to LLM. You probably just tell LLM, hey, look, I have this heavy MCP server schema, okay? And that's it. If you use it, I'm happy to provide to you, but you just know I have this, I can solve certain problem, but if you are not invoked to use it, I just leave it as a blind line to tell you it exists, to give you all the particular detail names of that because that's too heavy and useless for the moment. So this is called lazy schema loading. Okay. Another amazing feature of AI agent is they can call sub-agents. Okay. Hierarchical task delegation. For example, in antigravity, it has an inbuilt sub-agent called browser sub-agent. So if you making a web page, and then it can actually open Chrome for you and view this by himself and make some clicking and make some choices. You don't have to control that. You can see the mouse is moving around. That's pretty cool. So it doesn't do the web browsing itself, but it's let its sub-agent to do the work for you. Okay. So the good feature about this kind of task delegation is related to call this context isolated execution. Consider that you're a boss, right? You have someone, some worker working for you. You do not want to do the job that workers do, right? All you need to do is you give instructions, you let worker to do the job and come back to you with results. And in that sense, the context, the tasks, and all the processes a worker going through does not enter your context. Your context is called this structured state merging. So when the worker's task is completed, we just give you a report, okay? And then your context is, I gave instruction to someone. Now I get the result back. And for the worker, he may have a long list of working lists and he has worked a lot of context, lots of code there, but that is his context. His context will not pollute your context. In that sense, you save a lot of context, and that's very efficient for the main task you're doing. So this sub-agent idea is great. You can allocate tasks to different sub-agents. Actually, you are not. The AI agent have sub-agents to save context and make work more efficient. Okay. So what we really control in our project, and on this right-hand side, I give you a simple example of what we can do. This is a workspace, namely a folder. Okay. So in the folder, in the root of the folder, you should have a Gemini.md, or in the folder, you have a .agents folder, subfolder, and you have agents.md. Either is fine. And this because of versions, right? In the original version, we always use Gemini.md. So in the new version, they still allow us to use it. But this agents.md, this method is more commonly accepted in almost every AI agent, because if you do that, you can switch in agents. You just change to a different, this one can still work. So this is probably more normal standard, but we use Gemini.md in the past, so we just get used to it. So these two files, they are substitutes. This file or that file will write your basic workspace rules. For example, when you code, always check. When you answer me, do not say anything. Try not to be a sycophant and always be concise, and do not say useless words and those kind of instructions. Or you can say, hey, this is a project, the key folder is here. You can also use online server, the server address is here and such. Okay. And this is a general rule. You can also have some skills. For example, you can tell we have a deep research skill. The file name is called skill.md. This is a format requirement. In skills, you can have a different skills. And each skill in that subfolder, the detailed instruction should be saved in skill.md. These are actually just text files, right? And it tells steps how a certain task can be done. And these are usually will generated based on your working experience. And you actually can ask AI to generate skills for you, and you can just revise it. We do not have to write skill from scratch. This is good part. So this overall is called project level instructions. And if you have installed antigravity on your home folder, there's always a .gemini folder and configuration agents, and you can write user level instructions. And user level instructions will apply to all the projects you have used. So I usually do not impose this because my project has a very different flavor. So this, for me, this is a null file. But if you have a general rule about this, for example, you have to speak a certain language, then you can certainly put this in the user level. So you do not have to repeat it every time in a different project. So there's a global as project level, and there's some skill discovery. Same thing, the skill, if you save in this Gemini skills subfolder, then that is a global level skill. But actually, I think project level skill is nice, because I don't really imagine anything that's so global that apply to all the projects you have. Okay, so this is actually for what your initial folder may look like, and there's some other files related to your project and subfolders related to your project. Okay. So a little bit more about model context protocol. Anthropic proposed this one. So it's going to be a universal port for all the AIs. It's just AI's package, right? So LLM will know what tools it have and what can it do through all kinds of things, right? So there are ways of loading them. Luckily, we do not have to worry about this. AI will decide. If it's very light, it just load it right away. But if it's heavy, it's going to call lazy loaded. So that will only give the simplest instructions to tell LLM that, oh, such a tool exists. If you want to know details, ask me. And then LLM will decide if you use it later. Okay. So MCP is a standardized tool schema. So every MCP will have a universal tool call method such that LLM can call it. Again, MCP is also easy. So you just had to tell you, hey, look, I want some certain MCP. Can you install for me? Anti-gravity actually can do that for you. Or even it cannot do it, tell you how to do it. It's very easy to do. So, but not all MCP are very useful for your own particular task. So you need to try it, just to try it. So some takeaway and summary and or to best practice. So your local rules is very important. So you want to make sure that reflect what you wanted because every time your conversation starts will be fed into the LLM as a constitution. And then you should focus on the more selection. Right? If you select something, it's going to be really helpful for the LLM to understand that what you're working on. This is especially very helpful when you select code and try to ask it to explain to me. Yeah. When you think you have some repeated workflows, and then you should call your AI agent to say, maybe it's time to make a skill and it will make skill for you automatically. But you probably need to just take a look at it first. Usually just very small file and tell like 1, 2, 3 how to do that. If you think it's general enough, then you can make it a skill. Okay. So this is for how AI agent work, but I think the best way of understanding is still using it. So that's why I encourage you to try anti-gravity to solve some certain daily tasks that will be very helpful.